The program of Simons Symposia we have at the Niels Bohr International Academy is inspired by the series of meetings Niels Bohr already became famous for hosting at the Niels Bohr Institute in the 1920s and 1930s. The idea is that you bring in eminent scientists, the top level you can find around the world, and they are allowed basically to speak anything within their expertise, and it's not a narrow topic. And they also should enjoy the free and open discussion about topics that are perhaps a little bit outside their own field of expertise, because that can give actually a very fruitful, different angle on the kind of research one does. I have been fortunate to get a generous award from the Simons Foundation in New York that allows me to carry that program through. And the way I do it is that I invite a prestigious visiting professor, a Simons Visiting Professor, every semester over the period of 3 years now, so that's how it runs for the time being. So there will be 6 Simons Visiting Professors coming to the Niels Bohr International Academy over the next 3 years. Each of them stars in their own fields, and around those visiting professors we will build thematic programs where we discuss the science that interests them. This year we brought in outstanding cosmologist Vladislav Mukhanov from University of Munich. He's a cosmologist. He's also a quantum field theorist, you can say. He's a very general physicist with a broad range of interests, which suits us very well. We started out with a 2-week, rather intense workshop where we invited first of all, some of the colleagues of Vladislav Mukhanov, but also other outstanding figures in theoretical physics and theoretical cosmology.
Classical equation of motion. And we can actually find the field theory solution. Quantum, especially, it works now, especially explicitly in the conformal field theory.
Including eminent scientist Sasha Polyakov from Princeton University, who gave a 1.5-hour Blackboard lecture on turbulence, which is a topic that nicely covers a range of theoretical physics that goes from actually quantum field theory to classical field theory, and of course the classical problem in itself, turbulence. My proposal to the Simons Foundation, which fortunately went through and they provide us very generous support, was to identify 6 themes over the next 3 years where we want to focus. The whole purpose of this is actually that we're not fixing these themes now. We will do them as time goes on, because our idea is that we're not planning now what should be the theme 2.5 years down the road. We want to see how physics develops in the meantime, and we'll change accordingly.
Let's first settle the bet aspect. Now, here is 1 bottle of cognac.
Okay. This year was actually special because there was also a thing we had to settle.
In June 21 of the year 2000, a group of physicists were together in a meeting in Copenhagen dedicated to non-perturbative methods in field and string theory. They agreed upon having a wager on supersymmetry. Will a supersymmetric partner of any of the known particles be experimentally discovered within 10 years' time?
It was unfair to settle the bet before really the Hadron Collider had been turned on and could deliver results. So at a meeting around that time, we decided to extend the bet for another 5 years.
If one believed in a conventional supersymmetric picture of the world, this was a very good time for things to show up. This is really the 11th hour for things to show up.
And finally, we used the opportunity of this Simons program and this meeting in connection with the Simons program to have that old bet settled.
We should remember the LHC has collected roughly 1% of all the data that it's ever going to collect in its lifetime, so we do have quite a ways to go.
That's just a sign that there probably are small numbers involved, just like there were in the quark and lepton mass spectrum.
What's important to me is that we learn about nature, and I've always been really attached to data, so when the data keeps on coming out, and what we're learning from the data is that if it is supersymmetry, it's not necessarily the way that we had thought that it would look like.
This is a good time to scare the hell out of all the young people in the audience and tell them, don't follow your elders, these are great ideas. There's some indication that they might not be sufficient. Go out, look for something new and crazy and powerful and different especially.
The split was basically 50-50 among the scientists that participated.
If I had signed up to the bet, I would have voted no.
We've had a lot of discussions on a wide variety of topics, and many of the participants in particular enjoyed this freedom they had in the choice of topic that they wanted to discuss. And I think also the people in the audience enjoyed the variety and enjoyed being allowed to see developments in neighboring fields, not just in their own narrow topic. And they enjoyed the intense discussion and sometimes heated discussion and the feedback.
Good question, and we certainly will be thinking about it, but I don't know. But that's make perfect sense.
Since we had invited Slava Mukhanov to be the Simons Visiting Professor, and since Slava Mukhanov had just received a prestigious award together with Stephen Hawking, we thought it would also be a good opportunity to bring Stephen Hawking to Copenhagen.
I was last here in Copenhagen in 1970 at a conference on general relativity.
Stephen Hawking accepted the invitation, and we were extremely pleased to see that he could participate in part of the meeting.